Hi guys, welcome to the first lab session for COSC210. Today we're going to be looking at the introduction to SQL and using PostgreSQL, using the PostgreSQL database management system. The reading for today's practical is actually Chapter 4 from our prescribed text, the fundamentals of database systems. And today we're going to go through some of the introductory points, some of the things you can expect to cover over the pracs for COSC210. We'll create our first database using Postgres. We'll put some database tables in that database and actually insert some rows of data into those tables. We then have some exercises for you, and then you'll practice some of the retrieval queries that we introduce in Chapter 4 from the text. So welcome to the practical sessions, and through these sessions you'll be covering off on the use of SQL in depth, and you'll be implementing that in Postgres. We'll be looking at the development of database-driven Java applications and also database-driven web applications in PHP. So you'll be writing your own programs in Java and PHP and getting them to insert data into the database and actually pull data out. And we'll finish up our practical sessions at the end of the trimester looking at some NoSQL databases. So we'll be using a database management system called MongoDB to introduce those concepts, and we'll finish. And the final topic we'll look at are spatial databases, and we'll be using the spatial extensions, so the PostGIS spatial extensions for the Postgres database system to look at some spatial data, so data that represents points and polygons out in the real world. So in today's practical session, we'll start by using the interactive query tool for PostgreSQL, the PSQL utility, to actually interact with our database. First of all, we're going to create our first database. So before we can actually do anything and create tables, we have to create a database for those tables to exist in. And we do that first by using the create_db application. Now this is a utility that's actually packaged up with Postgres. It's already installed on Turing for you. And basically you just it's just a command line utility, and the only argument that goes with that utility is the name of the database that you want to create. So I've gone through and already created one called mwelch8_prac01, which we can see here. So I've gone through and I've actually created my database, and I can actually log into that database now. So once we've created our database using the create_db command, we can then log into it and actually carry out queries and work with our database using the PSQL interactive query client. So we can log into that just by using the name of the application, and we actually supply the database name as the only argument to that. Now, it's important to note that all of the users on Turing actually share the database. So when you create a database, make sure you put your username into the database name. Otherwise, other users will try to create the same name databases and will run into each other, and we'll actually have problems there because you can only access a database if you create it. So for example, I've created the database mwelch_prac_01, and I can log into that using the PSQL application, and that will bring up the prompt here once I've got into there. So the PSQL utility is just another program that's actually packaged up with PostgreSQL, and it has a complete range of command line options. So you can open it up with other databases and also with using other users and other accounts. And once you're in there, it has a full range of its own commands. So in addition to allowing you to actually issue SQL commands to the database, it has these / commands as well, which allow you to actually get metadata or information about the database itself. So for some common ones that you'll actually be using, the /DT command to display the tables in the database. So if we go and issue /DT to our database, you can see that there's no relations, no tables in that database because it's a brand new database. Some other examples that you'll become familiar with are /Q to exit. So if we want to exit Postgres, we just go /Q, and that brings us back onto Turing using onto the Turing prompt there. So we'll log back into our database. And we've got the copy command for copying from uploading data from CSV or flat files into our database, and the \i command can be used to actually execute a stored SQL file that contains a series of commands that we need to execute to either insert data or extract data from our database. So we'll see examples of their use over the next few pracs. So by this stage we've created our database, and it's now time for us to start creating some tables. And we'll do that using our first SQL command. And the SQL command is the create table command. And we create our tables by using the create table clause. We follow that up with a table name, and then we have a set of brackets that surround a set of attribute data type pairs. Now, the attributes are the names of the columns we want to have in our database table, and the data type is the data type for each of those columns. So in Postgres, we've got a full range of data types to choose from. Some of the most common ones are the numeric data types, so you've got small integers, regular integers, you've got floating points and real numbers. You've got character strings, you've got variable character strings, and you've also got your Boolean and date and time data types there. Now there's full specifications for all of the data types in the Postgres documentation linked here, and there's a full list there for you to go through as part of your reading. You can actually define a number of different database constraints, including primary keys, foreign keys, and unique values. So recall from lectures 3 and 4 we talked about the concept of keys and primary keys, and these are done by using the primary key. These are implemented using the primary key keywords to have our unique primary key on a table, and we can also use the unique keyword the unique command to create columns in our tables that only contain unique values. So we can create alternate keys for our tables using that command. So here we have an example of our very first create statement. We're creating the department table from our company database that we've been looking at through the lectures. And if we grab that, if we copy that text, we can drop it into our command line here and actually execute that table create statement. You can see here it actually, because I've got this SQL laid out on separate lines, it's pasted those separate lines into the command window, but it's quite happy to accept them. And then you just terminate that with a semicolon, and if you hit enter, it'll actually return this create table prompt if it successfully builds our table. And if we go and use the /dt command, we can view the contents of our database, and you can see here that we've actually created a single relation in our database. So you can see from the example here that this particular database table has four different attributes, 4 columns. Has the department name, department number, the social security number of the manager, and the start date of the manager. And we've specified that the department number is the primary key for this particular table. So that's been correctly created in our database. And once we've got some tables in there, we're going to want to actually represent the relationships between them. Recall from lectures 3 and 4, we talked about the concept of foreign key constraints. And we can do that by using the foreign key keywords, the foreign key clause, and we actually specify which attribute in our table points to which other attribute in our other table. So, for example, if we've got a table creation statement here for our employee table, and you can see that we've got a number of attributes specified using various different data types. We've set our primary key to be the social security number, and we use the primary key clause to do that. And we then set up these foreign key constraints. So the first one actually sets up that relationship that we talked about back in lecture 3, whereby each employee has a supervisor. So this particular foreign key actually references back onto the employee table. So we said that the super SSN attribute, which is this character attribute, here actually references the SSN field of the employee table. So the table actually references itself. A more common type of reference is a foreign key reference that goes to a separate table. So in this particular example below, We've got the department number from our employee table. It references the D number attribute from our department table. And we've set up some referentially triggered actions here. So if we delete a department record, any employee record that points to any of those, the deleted record, will have the department number field set to null. And if we update a department number field, then the corresponding department number fields in the employee table will be updated as well. So I've used the cascade on update cascade clause there to indicate that. So we can go and run that SQL command, see if it gives us any errors when we do so. We'll go through and decipher them if it does. So you can see there we've successfully created our table. Now we can go through and actually remove those tables using the drop table command. So if we want to drop our employee table, we can drop our employee table, and we can actually drop our department table as well. So if we drop our department table and go back through and check that there's no relations in our database, if we go back and try to create our employee table before we create our department table, we're going to generate an error. So if we go through and attempt to create our employee table, you can see that we've got an error here, and it's because the department relation that this foreign key constraint reference depends on isn't present. So we have to create our tables in such an order that these foreign keys can actually be specified correctly. So if we try to create the employee table first, there's no department table and no department number attribute to actually reference, so it brings up that error. If we go back up and grab the code for our department table though, we create that one first. Oops. Create that one first, then we create our employee table. It's quite happy to do things in that order because we're not violating any of these referential integrity constraints here. These foreign key constraints. So once we've got our data, got our tables built, we've then got to go and insert some data into them, and we can do that in a number of ways. And the first way we're going to look at is actually through the use of the insert command. So we actually use the insert into clause. We specify a table name and an attribute list. So this list of attributes are the attributes that we want to insert data for this corresponding set of values into. So if we've got our attribute number 1, value number 1 is going to be inserted into that one. If we've got attribute number 2 listed up here, value number 2 is going to be inserted into that one. And that happens all the way up to attribute n. So a rock solid example down below here is this example of inserting data into the employee table. So you can see we've specified the first name, last name, department number, and SSN attributes, and we've got a set of values for each of them to insert into. Now, points to note here are character strings, so string character data such as the last name, first name, and social security number. You'll see up here that these are defined using the variable character data type. Have to be surrounded by single quotes. Number data types that we're inserting don't have to be surrounded by single quotes. So you can see the department number, the DNO field, is an integer. It doesn't need to be single quoted. So that one's often a mistake that we'll make when we're inserting values. And the attribute list that we specify, it's actually optional, but if we don't include it, it uses just the order in which they're stored. They're physically stored in the database. So that can be unpredictable if we restructure the underlying representation of our database. The alternate approach for populating our tables with data, is to actually use the copy command. And we can do that, so the copy command in SQL actually has the copy keyword, we specify the table that we want to populate with data, and then we specify a path to a comma-separated values file that contains our data. Now, due to the permissions that are configured within Postgres, we actually have to use this command, this copy command, the /copy command, and this is basically a wrapper around the copy command that the PSQL client creates for us, so that we have the appropriate permissions to actually insert the data from the file. So you'll be walking through the use of the CSV upload when you run through today's prac. The final part we're going to look at in the first section actually covers deleting records from our table. So if we go through and insert some data into our table, so for example, if we bring up our department table, so if we go insert into department, and we want to insert data into which fields in the department table. We have our department name, so if we want to insert into D name, D number, and MGR/SSN and MGR start date. Values, and we'll specify department name might be computing, department number might be 4, the manager SSN, so it's a character field, we might just make one up, and our start date, which is a date, so make that 01-01-20114. Go through and we can see if that's going to work. So that has successfully worked. We've got this insert prompt here. And if we want to check that, we can use a select command to check that. So select all rows from, not capitalize that, you don't have to capitalize it, but I like to keep the keywords in capitals, from department. Run through, we can see that we've actually returned the row of data from our database table that we've inserted that. Now, if we decide that we want to delete that row of data, we can use the delete command. So if we go delete, delete from department, that command will actually clear all of the data out of our department. If we want to delete specific records, so if we go back and insert a record, we'll insert a second record here. We can be more specific. So if we again select, you can see we've now got, you can see we deleted all 2 there, but I'm going to go back, insert testing, insert computing. You can see there we've got 2 rows of data. If we only want to delete the testing department, we can go delete from department where D number equals 6, for example, and we've only deleted 1 row of data here. So if we go and view the data that's still in our department table, we've still got our row of data for the computing department. So that allows us to manipulate and insert and create data in our database. So we've got a set of exercises here for you to run through. So you'll be creating your database, creating some tables in your database. You can just cut and paste those table definitions in, and then you'll be actually importing some data from some CSV files into that database using the copy command. The final part of today's exercise actually gets you to create your own database schema based upon this relational database diagram that we've got here. So you'll be creating a series of table creates for that one, to actually with the appropriate foreign and primary keys, following on from the example of the company database. We'll finish up with the final section looking at our select queries, so our basic retrieval queries. So we saw some examples of where I used these before. We can actually select a set of attributes from a particular table and specify a condition for the records that are returned. The where clause, which is optional, contains the selection criteria. So if we wanted to select all of the columns from the employee table that have department number that are in department number 5, we'd specify in our where clause we want where our department is equal to number 5. If we want to get distinct rows of data, we can actually use the distinct keywords. This removes duplicate rows of data that might result if we start joining tables together. And we can string those conditions together using our logical and or operators. So run through those SQL select queries there, make sure that you actually execute them on the company database, and walk through and you can walk through and actually take bits of them out and see how they actually fit together. The final section here looks at some exercises where you'll go through and actually write some of your own SQL select queries there. So make sure you read chapter number 4 from the prescribed text, because it introduces all of the SQL stuff, and have that open as you complete today's exercise. So if you have any questions, send through some emails or get on the discussion board for those ones. Otherwise, good luck with today's practical.